Hi everyone, my name is Amy Upham, and I'm a Master's in Public Health candidate at Lenore Ryan. Today, we're going to talk about some statistics around alcohol abuse in 18 to 24-year-olds. And the first test that I ran was a t-test. And my hypothesis was that there would be no statistically significant difference of days of alcohol consumption between those under 21 and those 21 and older. Part of this is, does that 21-year mark, making it legal at that age, does that change drinking patterns? As far as skewness and kurtosis, I used the first 121 samples. I had to throw out one because it was lacking some data. But neither age group had skewed data for this comparison after that. According to the FSTAT, there was some unequal variance, so that's how I ran the t-test. And according to the t-stat, which was less than the t-crit, there's no statistical difference of days of alcohol consumption when split for age. Also, according to the p-value, which is greater than 0.05, which is a standard used, there's no statistical difference of days of alcohol consumption between the two age groups. And the effect size is really, really small, a Cohen's d of 0.35. So as you can see, 18 to 20 and 21 and over, really it's 21 to 24, doesn't seem to make much of a difference in terms of how many days they are consuming alcohol. The next thing I ran was a correlation analysis. And I said that there's no statistical difference between days of alcohol use and number of drinks binged. So there was some skewness in this under days of alcohol consumption. There was one data point that was 30, so somebody had consumed alcohol for 30 days. But the next highest one, which had a few, was 20. And so I did what's called Windsorizing, and I changed that one to 20, which took care of the skewness there. There was also skewness in the alcohol binge category, but I didn't want to change that because alcohol binge is part of the whole spectrum of alcoholism, and that abnormal distribution is inherent in the abuse and accounts for some deaths, actually. In fact, when I saw that somebody was drinking 30 days and their average number of drinks actually in that one particular data point that I took out was 15, that's somebody who should have died probably already from alcoholism, and may have. So in any case, the correlation between the days of use was R equals 0.1 or 0.714. Now the significance table only went up to 90 and then infinity, but somewhere between 90 and infinity, the 0.714 is much, much higher. So at 90, the R is 0.254, and that's the lowest for the highest or the lowest probability. So according to that measurement, correlation, there's no statistical significance. But we know that correlation does not always equal causation or statistical significance. So I ran the effect size, and according to Cohen, it was greater than 0.5. And I also ran a regression analysis, which the p-value was to the negative 20th. So definitely statistical significance. We reject the null hypothesis, and you can see the trend line goes up, and there's a 51% chance that A will influence B, which makes sense. If somebody's drinking more days, it's more likely that when they do drink, they're drinking more drinks. But I was surprised actually it wasn't a little higher. Then I ran a regression analysis. I hypothesized that age and days of alcohol consumption can be used to predict the number of drinks per alcohol binge. Skewness and kurtosis, same thing as in the correlation analysis. I Windsorized the one data point, took out the one that had no age data, and I left the alcohol binge skewness of 1.23 unchanged. And the analysis found that it can predict age and days of alcohol consumption can predict the number of drinks per alcohol binge with 53.3% accuracy. You see my regression equation there. I did a predictive versus actual graph. And you can see there that the trend line is it's not straight up, but it's definitely going in the right direction for correlation there, and that the R squared is 0.53. Again, not a huge predictive, but still some value there. And because I'm a nerd, I actually also went back and did the correlation between age and number of drinks per binge, because I had already done alcohol days. And there wasn't as big of a correlation, or not, there was no correlation actually in either one, but there wasn't as big of a statistical significance. In fact, there was really no statistical significance. So in this regression analysis, essentially that alcohol days, number of days that they're consuming alcohol, is probably leading to most of that relationship. So then I did an ANOVA because I wanted to find out the statistical significance in number of drinks during an alcohol binge between age groups. Again, especially since that first t-test showed us there was not much difference in age groups on one measure of alcohol consumption, I figured, well, there's no statistically significant difference in number of drinks during an alcohol binge either between age groups. And so skewness and kurtosis, same, I used the same data set and did the same thing with it. I did a one-way ANOVA, and the F-stat was not greater than the F-crit, and the p-value was greater than 0.5. In fact, it was 0.99. So I didn't find statistical significance. So the null hypothesis was accepted, as I thought it would be. But, then I did the Bonferroni post hoc test with a value of p being greater than 0.17. And it was much greater than 0.17 in all of these age groups, close to 1.0 actually in most of them. And so I knew that it was true, because this is a more conservative test, that there's no statistical difference. As far as the effect size estimates, they were very small, below 0.1, so almost non-existent. And again, showing age is not a huge factor in at least 18 to 24 when it comes to alcohol patterns, right? It's almost like once somebody starts drinking, they just start drinking. And how often they drink seems to have more of an effect. So to summarize, t-test, no statistically significant difference of days of alcohol consumption between those under 21 and those 21 and older. That was pretty clear, the t-test. There wasn't a lot of gray area with that. The correlation was a little bit more gray, because there was no statistically significant difference found just running the correlation, but the effect size was really large. So, and the regression analysis showed statistical significance. Now in the regression, which I did age and days of alcohol consumption, about it predicting the number of drinks per alcohol binge, that was a 53.3% accuracy. And as you remember, I think I mentioned that I think most of that relationship has to do with the days of alcohol consumption and not necessarily age. Because then again, with the ANOVA, I did, I hypothesized that there would be no statistically significant difference in the number of drinks during an alcohol binge between age groups. And I used 3 age groups for this, actually, not just 2, 18 to 20, and then 21, which is like the drinking age, and then 22 to 24. No statistical significance, effect size also really small, very clear. Age doesn't seem to play a huge factor in this. All right, well, thank you so much, and yeah, take care.